see here, going to do a screen share of this. All right. So as promised, I am not going to assume very much background knowledge at all, really any background knowledge at all. So if you've got experience using the command line at these first couple of days, or maybe even the first week or two, are probably just going to be a review for you. If you haven't done so already, get your machine booted up and ready to open a terminal. I'm going to go through some of the basic terminal usage stuff today. So terminal or shell, these are two words that you hear used interchangeably. Of course, they actually have different meanings, but it doesn't matter what the difference is for us. They're basically the same thing. So the first thing that we're going to do is open a terminal. So to open a terminal, in the bottom right, or excuse me, the bottom left-hand side of your desktop, there's a little button that looks like a TV screen. That's your terminal. So get that open. And then I'm going to reset up my slides here. So when you type something into the command line, there's a program that's called the shell that actually interprets what it is that you're typing in. Right? So the terminal is actually the window that pops up that is sort of managing whether or not you're typing in the terminal or you're looking at your, your websites, stuff like that. So technically, this would be sort of the terminal, and then when you type stuff in, it's the shell that reads what you're typing in and then does whatever it is you're asking it to do. Now, in order for the shell to work, you have to enter all of your stuff. You got to enter these shell commands in a specific way, right? And if you just think about how does the computer program that's trying to figure out what it is I need to do in order to figure that out, it'll make sense, right? So for example, you have to have a space between the command name and the command arguments, because that's the only way for the thing that is reading the stuff that you type in to determine what the command name is. So all command line entries are going to have a command name. That's going to be the very first part. And then they're going to have options and arguments. And we'll discuss what these options and arguments look like. Some commands don't take any options or arguments at all. So some commands are just a command. You type in that command, you hit enter, the shell executes that command, and then you see the output of that command. And again, all of these things, the command name, the options, and the arguments have to be separated by spaces. So if you have spaces in things like file names, it's possible to work with those, but it ends up being such a pain in the ass that you just don't want to put spaces in file names, right? Because you have to specify that, oh, this space is actually part of a single file name, and you have to do that, make a special exception for that. All right, so the first terminal commands. Open it up. Let's see what we got. When you open this up, you're going to be basically taking. You're going to have a prompt that's presented. My prompt is going to be different than yours, but you're going to see like a little blinker here, which is where your cursor's at, and then you're going to see some sort of symbol, and it might actually contain your username and the host name and stuff like that. This is called the prompt. Right? So I'm being prompted for commands. First command, the one that I just sort of type by habit whenever I go into any new directory, is ls. So if I type in ls and hit enter, I get a listing of all of the stuff that is in this directory. So you're going to see a lot of directories that have already been created for you. I've got different stuff on mine because I've already done some things on this machine, but you're probably going to have a directory called desktop, documents, downloads, music, right? And so all we've done here is listed the things that are in the current directory. So when we open up the shell, we start off in a folder or a directory, and this is the stuff that's in there. Now you can always tell what directory you're in using the command pwd, which stands for print working directory. Right? So if I print the working directory, I'm in /home/C.Clark. Yours is going to be /home/ whatever your username is. Dinkle little star. Is it two dinkles or just Dinkle little star? Yeah, so it's probably going to be a big long path for Dinkle little star. So the first two commands that we just entered are just commands, right? ls is a command name. pwd is a command name. ls is a command that takes, I mean, there are many different options, but one of those options would be tac-l. And for some reason, I use tac for dash. So when I say tac-l or tac-o, I just mean this little dash right here. And so the options that we specify are identified with these little tags. All right, so ls tac-l is going to, again, print out what's in this directory, but it's going to print it out in a little different way. It gives you more information. And the tac-l basically says list the things that are in this directory, but do it in long list format. So this is long list format. You can see that I've got the same directories in here, right? Bin, class, code, all the stuff's the same, but it is now printed out every one on its own line, and then it's also printed out some extra information about each of those things. And there's a lot of stuff in here, right? It's got the date and the time. This would be creation date. I have a bunch of C. Clarks on my listings. These are the owners of the file, and these are the group owners of the files. Right? So this tells you something about the permissions. And then you got all of this stuff over here on the left, which is a complete listing of file permissions. Now, I'm not going to go through the details of file permissions right now. File permissions are covered in the textbook, so you can read about those in detail later. But the thing to notice here is that, and you probably don't have this yet, but I have these things in blue are all directories, and this thing in green is a file. So I've got one file and a bunch of directories in this directory. And if you look at the very left-hand side, the long list will tell you what are files and what are directories. Anything that starts with a D is a directory, and anything that has a dash there is a file. Well, I guess it could be a link or something like that. But there's going to be some exercises where I ask you to determine how many files there are in a given directory, or how many directories there are. On the, I guess in Linux in general, extensions have absolutely no meaning, right? Any extension that's used for a file name is purely by convention, as opposed to, if you've used any Windows machines and you try to rename it and you take off the extension, Windows will warn you that it might make that file not work anymore, because Windows looks at like the extension and says, oh, this is docx, which is docx, which means I need to open it with Microsoft Word. That is not the case here. The extension is not used to figure out which program to use. Yes, Tyler?
There's a 4-digit number on all of your directories, but there's a 5-digit number.
That has something to do with size. It's like the size in bytes is what it is. So my point is that it is possible for a file to not have an extension and look like a directory, but if you look at this left-hand side here, there won't be a D listed for that. So that's how you tell the difference between directories and files. And then the terminal that we're using actually has a nice feature where it color codes it. So all this blue means directory, and the green is a regular file. Right? Now, that's not guaranteed to be available on every machine, but if you've all installed this Linux Mint Debian edition, then that's another way to tell whether or not you've got directories or files. All right, the next option that we want to look at for ls is tac-a, and the tac-a option means list all files in this directory. And if I type ls tac-a, what I see are a bunch of files and directories that didn't exist before. Well, it's not that they didn't exist, they didn't show before. So tac-a means all. On Linux and Unix machines, so I'll just, basically everything that I say also applies to Unix machines, but I'm just going to say Linux machines. On all Linux machines, hidden files are not, they don't have a special property, they just have a special name. If you name a file that starts with a dot, then it will be hidden. And hidden just means that by convention, the things that list out files like ls won't show you those by default. Right? If you opened up a file browser, hidden files would be hidden by the file browser. But all you have to do is rename the file in order to make it visible. So there's no specific property that makes the file hidden. Like if you try to hide files on a Windows machine, you have to right click on it. You have to go into the properties. There's some sort of property that says to hide this file. Hidden files are just a naming convention on the Linux machine. And so you see a lot of these these files that start with the word or the character dot, because they're just files that are contained in here for configuration data, and you don't want to see all that stuff every time, right? These aren't your regular data files. Like .vim is where the Vim editor puts all of its stuff. You're usually not interested in that. .cache is where some programs write cached information, right? So these are just files that are hidden so that they don't clutter up your listing whenever you type ls. And then you can give more than one option. So let's say that I want to long list all the files. So I want to see the files that are hidden, but I want to write those or print those in long list format. I just do ls tac a tac l. So I got to have a space between all of them, right? Because the shell that's reading this is going to read the first word. It sees a space and says, okay, the command is ls. Next option is a, and the next option after that is l. And so you'd see the same thing, right? And again, the naming convention, files that start with a dot are hidden. There's nothing else that indicates that they would be hidden. They're just not going to be printed by ls if you don't give the tac a option. And then these blue ones are the directories, and you see that there is a D in front of the front of the line for the blue ones, and then the files don't have a D in front of them. So one of the most common things to do is to type in something that doesn't exist. Like, so if I type in ls tac l without a space, I'm going to get a complaint that says command not found. So why is it saying command not found? Well, because every time I type in a command name, the shell, which is the thing that's responsible for doing what I tell it to do, is looking for a command that has the name that I just gave. The only way that it can tell that the command has a given name is if I put a space after the command name, right? ls tac l is a perfectly legal command name. You could write a command that had that name, and this would mean you would be saying, hey, I want to run ls tac l, right? So that command doesn't exist, and so I get a command not found error. That just means that I need to put a space between the command name and the tac l. So this can be tricky or difficult for new people because it seems as if the error message doesn't describe what's going on, right? What you want it to say is, hey, you need a space between your command name and your options, idiot. Please do that, right? But that's not what it says, because there might be a command named ls tac l and it's looking for it, right? And it doesn't see it. So there's a downloads directory in your home directory, which probably doesn't have anything in it. I think mine might have something in it. Nope, mine doesn't. So this is an example of me giving ls. We've already given ls options. If I type ls without any options or arguments, I get a listing of the current directory, which is my home directory. That's the directory that I'm in right now. If I do ls tac l, I change how ls prints the contents. The other thing that I can do is I can give ls a argument, right? There's no tac in front of it. And then instead of listing the stuff that's in the current directory, what it does is it lists the things that are in the directory that I specify. So I have a directory called downloads. And if I look at the output of ls before, right, there it is. So I've got downloads. So all I've done is said ls downloads to see if there's anything in the downloads directory. So I don't have to go into that directory in order to see if there's anything in there. I can give ls the directory name and it will do it for me. And again, arguments have to be separated from the command name because the shell doesn't know if what you're trying to type in is an actual command or if it's a command with some arguments. So you'll get an error. All right, so this stuff you're not going to see because this is just the stuff that I have set up in order to automatically run these demos that we're doing. All right, so the first thing that I want to get you started on is tab completion and command history. If you start typing something in and you hit tab, you'll get a listing of all the things that you might be trying to type, or if there's only one option, it will auto-complete that. So I never type the whole argument into my command line, right? If you hit tab, it'll complete it for you. And so you should start using tab immediately. Tab is really good if you don't actually know, like if you know that a command starts with a certain letter, but you're not sure what the rest of it is, you can type in that first letter and start hitting tab, and it'll start showing you options. So you should learn how to use tab. And then the other thing that you should learn how to use is command history, right? So command history is everything you type in the command line is going to get saved, and you can go back through that history if you just hit the arrow buttons. So let's see if I've got any. All right, so for example, if I type in ls capital D and I hit tab twice, it will show me a listing of the things in that directory that start with capital D. And then if I go ahead and type like an O and a W, right? So there's only one thing that starts with DOW, and I hit tab, it'll auto-complete that for me. This is really useful if you are, if you're gonna, as we'll see, like if you're gonna try to navigate to different directories on the system, right? Really long path names, you don't have to remember. You can just, if you remember the first couple of letters of every directory name, you can hit tab and it'll auto-complete for you. So if I type in L and then hit tab a couple of times, and if you do this, it's going to come up with a little thing that says, do you want to show all 120 options, 137 options? Then it's going to print out every command name that starts with the letter L, right? So then you can type in L, go ahead and type in S, hit tab, it'll command complete for you. So you get tab completion for command names, and you get it for arguments, which is really nice. So you should use tab a lot. And then the other thing that you can do is if you hit the up arrow on your keyboard, you'll see the previous command that you just typed in. And if you hit it again, you'll see the command before that. And so if you have, if you've forgotten the command that does something, you can use the up arrow to try to go back through your history and remember what that command is. So if I hit up multiple times, I get the commands that I've done. Let me just do a couple more examples of this. So I'm going to hit up. I'm going through my command history. All right, if I find something that I want to run, all I have to do is hit enter. Now that command that I just ran goes right back into my command history, right? The most common thing that you would use this for, especially early on, is if you do something like this, ls, tac A, tac L, you say, oh, well, I forgot to put a space there. You don't have to retype everything. Just go up in your command history and then edit that command and then hit enter and you'll have it. So if you make a typo, you don't have to retype everything out when you try to rerun that command. You just go back through your command history, edit the command line, and then rerun it. Yeah.
Is there a way to clear out all of the things that are printed out?
Oh, you mean on the screen? Clear, we'll do that for you, if that bothers you. Like to keep a tidy terminal, do we?
It's messy. You don't know what you're working with.
I like that your terminals are just slightly transparent.
All right. Navigation. All right, so we've done command entry. Got a command name, got an argument, you got some options. So navigating on the command line is basically just, there's a couple of commands that do it. Like for example, we already saw that pwd, this print working directory, will tell you what directory you're in. And then ls will tell you if there's any files or directories in there. And then there's a command cd, clearly the best command of all time, that will change directory. That's how you go into a directory. So like I said, I'm not going to add, I don't think you should be using the file browser to do your file manipulations, but let's at least look at what's going on so that we can sort of get an idea of how the command line and the traditional file browser are related to each other. So down here at the bottom left, there's a icon that says file browser. It's this little silver, right? So this brings up something that shows you your files. If I click on the address here, I've now gone to the very, very top directory of my system, right? This is called the root directory. If I click back on this C Clark, you remember when I typed pwd in the command line, I got /home/C Clark, right? That's this directory. Look at the stuff that's in this directory. I have class, code, desktop. So when I open up a terminal, I automatically get put into this directory. If I ask it to list the contents of the directory, I get a listing of this stuff. So for all of the files and directories that you see on the command line, there is, you could go in the file browser and find those files and directories, right? But the reason that I I'm going to advocate that we learn how to use the command line to do this type of stuff from the beginning is, for example, if you need to delete 1,000 files at one time, which is going to be very common if you're using the computer to do like data analysis, right? Let's say you've got some data that you collected, you write some stuff that does an analysis on the data, and it ends up generating dozens of files. You don't want to go through and do the control click through every one of those files, right? Because you always end up, at least I always do, I always end up accidentally missing one, and then they all disappear. So then you have to go back through and do this, right? From the command line, it's very simple to do that. It's very easy to delete a bunch of files all at once. So we might as well just learn how to do all of the file manipulations at the command line, but just know that what we're looking at is the same sort of hierarchy of files and folders that are presented in a regular file browser. All right, so let's navigate around the system a little bit. So I've got this file browser open. If I go to the root directory, right, which is the very, very top directory, I see a list of directories and files. In the root directory, there's always going to be one called home. The home directory is where the user home directories are stored. And your home directory is basically where all of your files get stored. So from the very beginning, Linux was set up, because Unix was, to be a multi-user system. So if I log into my computer and I do some stuff, and then Bloss logs into my computer and does some stuff, we should have our own separate set of files. And we don't need to be, I should be able to do all my stuff completely separate from what Bloss does. Rusty Shackelford, I'm sure, has been writing email hacking code. It's probably in here, right? So every user on your system is going to have a directory in this folder. These are where the home directories are stored. So all of my user files are going to be then stored here in this directory. All right, so first thing, in order to get back in the home directory, just in case you're not, is to type cd. So if you type cd without any arguments, it'll take you straight to the home directory. Right? So do that just so that we make sure that we're all in the same place. All right, so I'm going to do, again, it's basically habit. I type ls in every directory that I go into. So let's make sure that I'm in the home directory. Yes, okay, I see a list of all the stuff that's in my home directory. I'm going to change directories into the desktop directory. And then I'm going to print the working directory to see what has changed. And so if I print the working directory, I now get something that tells me that I am in the desktop directory, which is under, I guess I've sort of been, I haven't explained this, but it's probably obvious. Directories names are separated by these slashes, right? So desktop is a directory name. It is in a directory called C. Clark, which is in a directory called home. This whole thing right here would be called the path to this directory that I'm in. Is there anything on the desktop? Well, there aren't any regular files or directories on the desktop, okay? So let's do this. Let's create a file. Let's name it file.txt. And I can do this by just right-clicking on the desktop. I'm just going to create an empty file, and then we'll see if it shows up in this desktop directory. All right, so go to my desktop directory, which is the desktop. I'm going to right-click on the desktop, and I'm going to do create document, and I'm going to create an empty file, and I'm going to call this file.txt. Type enter. All right, now I'm going to go back to the terminal, and I'm going to see what changed. So before there was nothing in this directory, and now if I list the contents, I see that there's a file. I see that the file is not a directory, right? Doesn't have the directory thing turned on. The C. Clark user apparently created it and created it January 3rd, 1355, which is about right. And there's nothing in it, so apparently the size is roughly 0. All right, now let's do the same thing with the directory. So I'm going to go to my desktop, and I'm going to create a directory, and I'm just going to call this directory temp. So I'm going to, not that desktop, this desktop. So I'm going to create a folder. called temp. And remember, folders and directories are the same thing. There's no difference. They're just a different word for the same thing. So I've got a folder and a file on my directory. Now on my desktop. There's this stuff over here which isn't showing up. That is apparently because this desktop is sort of special. The computer itself is not creating anything in the desktop folder that presents this computer icon and my home directory icon. It's putting that stuff on top of the desktop that it's rendering. So the only stuff that actually shows up is this temp directory and this file, .txt. So if I type ls-tacl, I should see now a directory and a file. Okay, so that's, I mean, anytime you're in the terminal, you're basically in a directory somewhere. If you do anything, you're going to be affecting the files that are on your system. And so you can always find those files in the file browser if you need to. All right, so I'm going to type cd with no arguments, which is going to take me back to my home directory. This is a good one just to get you back to the top of your user files. So if I type pwd just to make sure that that's what happened, I see that the directory is now /home/cclark. So I'm going to do ls. I'm going to tell ls to long list the files that are in my desktop. So I'm using an option and an argument to ls. So command name is ls. Option, there's only one, it's tacl, and the argument is desktop. And desktop is the name of a directory, so ls is going to show me what's in there. And so I don't have to go into that directory to list its contents. I also don't have to, yeah.
These commands are case sensitive, right?
The commands are case sensitive, yes, that's correct. I also don't have to cd into a directory and then cd into a subdirectory. I can do that all at once. All right, so if I wanted to go into the temp directory that's on my desktop, I could just cd into the desktop/temp directory. That would take me straight into the subdirectory of desktop. If I print my working directory, I now see that it is /home cclark desktop temp. Okay, so the cd command takes directory names, but directory names can be given at more than one. So you would not want to, for example, type cd desktop space temp. You got to specify the directory path with those slashes between them. Yes, Tyler.
What's the difference between lowercase a and capital A? Because if you look up all the different options for ls, it doesn't really make a lot of sense.
I never use capital A, so I don't know.
Because it just doesn't say much.
Yeah, I find tacl and tac-a lowercase are pretty much the only things that I ever need out of the ls command. So I'm sure it does a bunch of things.
It lists everything except for dot. Yeah, I agree with that. Okay.
All right, so I've been talking about these command arguments and options. So let's take a minute to maybe formalize this a little bit more. Commands take arguments. Right? Arguments are the things that the command is gonna do whatever the command does too. So for example, if I do cd desktop or ls desktop, I'm telling the cd command and the ls command to do what it is that you do on the desktop directory, right? So cd changes the current directory to whatever it is you give it as an argument. So it does that with the desktop directory. ls lists the contents of whatever you give it as an argument. And so it does that. And then the options basically change the behavior. So we've already seen tacl and tac-a for the ls command. A lot of commands take different options. So it doesn't change what the command does, it just changes how the command does it, right? So you basically have, when you're typing in a command at the shell, you've got the, what do you want to do? That's the command name. What do you want to do it to, which is the arguments that you give that command, and how do you want them done, which are the options. And a lot of commands will take, I mean, there's only one command name, but a lot of commands will take multiple options. Like ls-tac-a, tac-l takes 2 options, right? They also, a lot of commands will take multiple arguments if it makes sense. Now, it does not make sense for the cd command to take more than one argument, because what would it mean to change my working directory into 2 different directories? But it does make sense for the ls commands to take more than one argument, because I could say, hey, show me what's in the desktop, directory and the downloads directory at the same time. Right? So they'll take commands and options, possibly more than one of each. So now we're going to start talking about how do I create and delete files. So the commands that we're going to use to create and delete directories are going to be mkdir, which stands for make directory, mv, which stands for move. And it turns out that mv is what you use for renaming a file. Like if you just want to change the name of a file, you move the file to its new name. Right? There is a rename command, but it's only for doing batch renaming. Like if you want to rename 100 files all at once, you would use the rename command. If you just want to rename a single file, you use the move command. And then rm is remove a file or directory. So the make dir only works on, it creates a directory. Move can be used to move files, to move directories, or to move both. Right? You can move files into directories. You can move a directory to a different directory. You can move a directory into a subdirectory. There's a lot of different ways that the move commands might work depending on what you're asking it to move. And then the remove command does directories and files as well. But if you're going to do a directory, it turns out you have to give the remove command an option that tells it, hey, delete everything that's in this directory as well. By default, it's going to complain. So let's see what that looks like. All right, I'm going to go back into the home directory. So I'm going to start off with the home directory. If you're not in the home directory, you can just type cd to get you to the home directory. All right, again, like I said, this is sort of a nervous tick of mine. ls, right? Sometimes I type ls twice in a row for no reason at all, other than I can't remember what it is I'm doing in this directory. I'm trying to think, and I just type ls, right? So let's make sure that we're where we believe we are. I'm going to go into the desktop directory. Now remember, I created a couple of files. Well, I created a file and a directory here. And the file is called file.txt, and the directory is called temp. So I'm going to use the remove command to remove that file. Right? So all I got to do is give the name of the file, the remove command deletes it. This is not move to trash. This is delete from system. Okay. So one of the things that always occurs with new users is, I get this question a lot. Where did the deleted files go? Like if you delete something that you didn't mean to delete, where do you go to recover that? And the answer is you don't. Right? They're not placed in a special directory that you then flush out. So Windows is set up to move stuff to the trash, which you can always go to the trash can and get stuff that you deleted by accident. This is going to delete it. So it's going to be gone. There's not an undo. Now, if you search, how do I get a deleted file? There are tools that can work, but they're very complicated, right? It's not guaranteed to work. All right, so I removed the file.txt, and now it's gone. It's not in my desktop directory. And if I go look at my desktop, sure enough, the file is right around here, and it's gone now. So now I'm going to remove the temp directory. But this is where the remove command needs an option. It's going to complain. If I try to remove temp, it's going to tell me that it's a directory. And I don't know what the reasoning for this is, but it's nice. It keeps you from accidentally doing something that you don't want to do. Basically, the remove command takes an option called TACR, which stands for recursive, which says, delete this directory and everything that's inside of it. And if there are any directories in there, delete those too. And if there's any directories in those, delete those. So it's going to do a recursive delete. And so you have to give it an option to tell it to do this recursively, right? And so it doesn't matter if there's stuff in the directory. Like if the temp directory had some files in it, it wouldn't ask me if I really want to delete it because it's full of files. It would just do it as long as I give the TACR option. So if I go to if I list my directory contents now, it's gone. So that's how you remove stuff, right? RM for files, RM TACR for directories. If you give TACR, it will remove files and directories, right? So if you do RM TACR and give it a file name, it'll delete that as well. So I'm going to go back into my home directory, list my home directory contents. I'm going to create a directory called temp in my home directory. This is one of my the directories that I typically always create on a system that I use. It's basically used for stuff that I have, I just want to do some stuff real quick that I don't want to save. I always know that I can go into this temp directory and delete everything and I should be fine, right? I shouldn't put anything there that means anything significant. So I always keep a temp directory that's in my home directory. And so if I do make dir, I get a temp file, a temp directory that was added, right? So on the desktop, we did right click and said create a folder. That's how we created that folder last time. We could have went into the desktop directory and then ran the make dir command. Right? That would have done the same thing. So I've created a directory called temp in my home directory, and then I'm going to go into that directory. And I print the working directory to show that, in fact, my current working directory path has changed. So if I do cd without any arguments, I go back to the home directory. So I'm going to make a couple of other directories, and so you can list more than one directory at once. So this make dir command is going to create two directories, one called temp1, another one called temp2. It's going to do that at the same time, so I don't have to over and over and over again type make dir for every one of them that I want to create if I know I've got more than one. I look at the listing in this directory, and so now I've got temp, temp1, and temp2. All right, now I'm going to move. Yeah, go ahead.
So I've been doing exactly what you've been doing. And after I do the make dir temp, no file appears. I'll check the directory, nothing appears. So I tried running it again and said that I can't do that because there's a file already there with the same name.
You didn't accidentally begin it with like a period, did you?
No.
This is in your home directory?
Yeah.
Pause. Let's see what you got here.
And so went there, and then it just kind of freaked out me, so I just came back down here. And I checked for it, couldn't access it. Oh. It's just not appearing. Sorry, I wasn't reading it apparently.
It was just a simple case of oversight.
Yeah.
Anybody else having troubles yet? No? All right, good. All right, so I'm going to move temp1 to temp. Now, what actually happens here depends on what exists. So if there was not a directory named temp, this command would move the directory temp1, would basically rename it to temp. But since there is a directory called temp, what it's going to actually do is it's going to move temp1 into temp. Right, so it's going to put it in to the temp directory. So the move command, which will take multiple arguments, will move one file to another file. If the last argument, which in this case is this piece right here, the last one, if that's a directory, then everything that comes before it just gets moved into that directory. If it's not a directory, then it tries to create that thing as a file. All right, so I just moved temp1 into temp. And if I do an ls, I see that temp is gone, or temp1 is gone, right? I've got temp and temp2 here. I'm going to move temp2 into the directory that I just moved in to temp. And so this is another example of I don't have to be in the directory that I want to move something into. I can just give the full, or not the full, but I can give more than one directory at a time in a given name if I separate the directory names with slashes. So this command, move temp2 into temp/temp1, is going to put temp2 into the temp1 directory, which is already in the temp directory. So I'm basically nesting these directories down. And if I list the contents of temp, I see the directory temp1. If I go into temp and I list its contents, I see temp1. If I list the contents of temp1, I should see temp2, right? Which, there it is. So I can move files or directories into other directories by just specifying the last arguments to move to be a directory name. All right, so I'm going to remove this temp 1 now. Now, temp 1 contains temp 2. All of these are going to be deleted with this remove command. I got to put the TACR on there so that it does it recursively. So those are the basics for creating and deleting directories. For creating files, we're going to do things like, open up a text editor and actually create the file. But to delete files, it's going to be the same thing. Always, the rm command is going to delete files. To rename files, it's going to be the move command. So I want to take a minute here to specify, sort of just explicitly call out the difference between absolute and relative paths. So what I've been doing, like when I type in temp/temp1, I'm actually giving what's called a relative path name to that directory. So the pwd command prints the absolute path to the current working directory. Okay, so that's the directory that you're in. And the absolute path is the part that has the /home/cclark/ wherever, right? So in Linux, every directory is a subdirectory. There's basically a tree. And everything has, if you go up the directory tree, you're going to end up at the very top. And everything has to be below that. That's in contrast to if you have multiple drives installed on your Windows machine, you're going to get like a C drive and a D drive and a J drive. Those are not all underneath the same directory structure, right? Each one of those drives has their own directory structure. On Linux, everything has to be below what's called the root directory. So if I say root directory, that's the very top of your directory tree. And if you go into the root directory, the root directory's name is just slash. So you can go in to the root directory by specifying just slash. So you go cd slash list of the contents. This is the stuff that's in the root directory. I mean, most of this stuff is all system files that are being used for your computer, right? So it's somewhat analogous to if you go to the root of the C drive, you're going to find a directory that's called program files, which is where Windows installs the programs. There's a directory called bin on Linux machines, which holds a lot of executables. Let's see if there's anything in there. All right, so I think ls might be in here. Yeah, so the ls command, well, the ls command has to be a program. The ls command is stored in the directory /bin. Right? These are a bunch of other commands that are stored in that directory. So /bin is sort of like program files. Not very much like it, but it's sort of like it. So that's the absolute path. When I do, so if I go back to my home directory and I type pwd /home/cclark is the absolute path because it starts with a slash and that first slash is root. Home/ is the name of the subdirectory in root. So if I go back to root, home/ is right. Derek, oh no, Derek can't see directories. This one right here, right? So there's a subdirectory in root that's called home/. If I go into home/, there's a directory called cclark/. Now typically you don't say the slash part. And that is the absolute path to where I am. So that tells you uniquely where you are on the entire system. Those are called absolute paths. So I've already said that every user basically gets their own directory to store files in, and we call that directory the home directory. So, mine are stored in /home/cclark. So it's that cclark is my home directory. Rusty Shackelford has his own home directory. And then relative paths, this one right here, basically give the location of a directory or file from the current directory's position. And there's a couple of special file names that can be used, right? A couple of special directory names. Dot is the name of the current directory, right? Now, especially when you first learn about it, it seems kind of pointless to name the current directory dot, but if you type in ls dot, it will list out the contents of the current directory. Right? So we know that ls does that. If I type in ls dot, it does the same thing. So dot is just a shorthand for the one I'm in right now, right? Which there are times where you actually have to use that. And that's the relative path name to that directory. The absolute path name to this directory would be /home/cclark, right? And so I can ls the absolute path name of that directory, and I get the same listing. Yes, Corey.
Could you be in your home directory and then ls a different directory path? Look what's in that path.
Yeah. So let's do ls/bin. So that's the bin directory from the root, right? So that's not in my home directory. I can give the absolute path to ls, and it will do that
You're
for me.
still in your home directory.
And I'm still in my home directory. Yeah, that's right. And then there's another special directory name, .. And .. is the directory above the current directory, right? And that one's used a lot. Like if you cd into a directory, to get back to home, I've just been typing cd with no arguments, right? But if I go down into a directory and I want to go back up, the way that I get there is I do cd .. And that specifies the parent directory. So let's look at ls/home, right? I know that that's the parent directory of my home directory. If I do ls .. I get the same listing, right? So ls .. is the /home directory. Yes. Those are probably, I'd have to, let me do a, root. I don't know, actually. Bless you. Bless you. Actually, it looks like the thing, there's some permission here. This is S instead of X. So whatever that means, the shell is displaying those formatted in red. So the root directory, right, if I do pwd, ls .. should be the contents of home, and ls .. should be the contents of root. And if I keep going up, and eventually it just prints out the contents of root again. So I should be able to give the, let's look at the absolute path name to the bin directory, which contains a bunch of binaries, versus the relative path name to the bin directory, which I know is up 2 directories named bin. I get the exact same output, right? So that's how you list the contents of something that you know is like in a directory next to you, right? If you think about the root of your file system is at the top, and as you go down, like as you cd into deeper and deeper subdirectories, you're going down, right? You've got a set of directories that are basically at your level, and you can always see what those directories are by lsing the contents of the parent directory, which is .. All right, I got a sandbox, but we're out of time. So we're gonna do sandboxes on Wednesday when we get here. So make sure that you can access the website, because the sandboxes are gonna be placed on the website. I'm thinking of you in particular, Bloss. Blackboard's opened up now. There's a link to the website. Make sure you can get to that so that we can download the sandbox next time on Wednesday.
It's in there now.
Good.